So let's have a look at inner joins, and I'm going to look at them in a little bit more detail here. Now we know that there is an actual operation for a join, and it's represented by that little sort of bow tie symbol here. And the way that we've done joins in relational algebra and SQL is by using a combination of Cartesian product and selection. So there's sort of the first and the third operation in this table. And what we've done is something like this. We basically, we've got two relations. You can visualize them as two tables, and we've combined them using Cartesian products. So there's that cross operation there, R combined with S. And of course what happens there is that everything from the first table is combined with everything from the second table. And what we really want to do is we want to keep the records that are appropriate. So in other words, some condition is applied over those rows so that only a subset of those rows, the valid rows, are the ones that we retain. And the way that we do that is to use a selection. And that's what we've got outside the brackets. So we apply a selection on some condition, some predicate f, over the big resulting set that comes about once we've combined R with S. And the example that we've used involves emp and department. So we Cartesian product emp and department together, and that's what we've got inside the brackets. Note the use of the cross there. And once we've combined those two tables, those two relations together, what we then do is we find the rows where, and we've got a shared column, we find the rows where that shared column is the same. In other words, the department number from the emp table matches the department number from the department table. And it looks like that. Now that's an inner join that's being done using a Cartesian product with a selection. And there is an alternative notation, and that's the actual sort of true inner join notation, which uses this bow tie. And that's alternative notation for an inner join. I mean, it's the same thing. So either you could write down a Cartesian product with a selection, or you could simply use that bow tie notation. And what we do, if we're going to use that bow tie notation, we put the relations either side, and underneath we write the predicate, we write the condition. So if we were going to write down an inner join using this symbol for inner join with the emp and the department table, it would look like this. So we're going to combine the emp relation with the department relation. And what condition are we going to apply? What predicate are we going to apply? We write that underneath in sort of smaller subscript like that. Department number equals department number. And that would give us this. Now, the way that we do that in SQL is like this. We basically use the Cartesian product and the predicate. So the second line, that's where we're doing that Cartesian product. And of course, instead of using a cross, we use a comma. So we go emp, comma, department. And then on the third line, we do a selection, and we do that after the where clause. Now that's an implicit inner join. We're not explicitly saying in here that we're going to do an inner join. We're actually creating an inner join by doing those two things, by doing a Cartesian product and by doing that selection over some condition, over a predicate. And we can run that against the table, and we can get our two tables combined. Now that's an implicit inner join, because we're not actually saying anywhere here we're doing an inner join. We're actually using a Cartesian product and a selection. Now it turns out that there is an explicit inner join syntax, and this was introduced perhaps because people find inner joins complicated. It gives us another way of doing an inner join, so it behaves in exactly the same way as the other syntax. We will actually explicitly write down that we're going to do an inner join. So let's see what that syntax looks like. Here we are. Now if you look at the words in blue, you can see we've got some new reserved words here that we can use. So we've got select, that's the same as before, and we go from, but rather than separating the relations or the tables with a comma, what we actually do is we actually put the words inner join between the tables. And instead of using where, we use the reserved word on. Now that's quite strict in the original specification, but I know that some database implementations, they allow you to go select from where. But in its original form, it was select from on, and then we have the condition that's going to apply to actually enable that Cartesian product to be turned into that inner join. So probably best thing to do is to look at that as an example. So we do the same one again, emp and department. This is what that explicit inner join syntax looks like for the emp and the department table. There it is. So we go select star from emp inner join department. So instead of having a comma, we now actually write the words inner join in that space. And then we've got a condition, but instead of using where, we use the word on. And we can run that and it produces the same table. Now it's very much up to you which one you want to use. I tend not to use this because I could just simply remember the Cartesian product and the selection. It's extra words that you have to remember. On the other hand, if you think it works for you, then you can use it. That's absolutely fine. So those are inner joins using an implicit and an explicit syntax. But what these things have in common is in both instances, we've been doing a test using equality. In other words, if you look at the third line, you can see we're saying the department number in the first table is equal to the department number in the second table. But not all combinations of tables are done by using equality. Not every time do we say this equals that. Sometimes we can use other operations, and we can use things like less than, greater than, not equal to, and things like that. It depends on the context of the tables. Let's look at the example that we have with the tables here. We have a grade table and an emp table, and these are this is a great example of how do we combine these tables when there is no shared column. Now the way that the grade table works is that, and often this is used in the public sector, jobs are on a particular grade. So let's say that you were being appointed to a job. They might say this is a grade 3 job, and then that would mean that the salary range would run between 24 and 2,999. And if you wanted a promotion because you wanted more salary, then you'd have to apply for a grade 4 job, for example. So the key question here is, how do we know which grade people are actually on? Now, when you're doing a inner join on equality, often you're looking for that shared column. Where's the shared column? So when we're combining emp and department together, we know that there's a department number column in both tables, in both relations. But of course here, if you have a look, there's no shared column. There's no shared column between grade and emp. So how do we actually combine these tables together? Well, have a look at March. Now the way that we're actually going to work out what grade March is on is if you scan across, you can see that March is on 18,000, that's the salary, and that would mean they were in, and now if you scan across, look at the grade table, you can see that that is grade 1. So think about how you actually work that out. What you did is you did a comparison between salary, and then you looked at the ranges in the low sal and the high column in the grade table to find where that actually fit. And of course 18,000 fits between 17 and 21999. So that means they're in grade 1. So let's try and write that down in a form that we can actually use in relational algebra and in SQL. What we're actually saying is this. We're saying combine these tables together, and we want to keep rows where the salary is greater than or equal to low sal and the salary is less than or equal to high sal. In other words, sal has to fall between those 2 points, between low sal and high sal, for these two tables to be connected together. Now if we write that down in relational algebra, it would look like this. So look at the first one, the CP and the selection notation. We're going to read that from right to left. We're going to combine emp with grade. So that's the same as the Cartesian product that we've done before. But of course what we want to do is we only want to keep particular rows. Which particular rows are we interested in? Well, the rows where this condition is true, this predicate is true. keep the rows where the salary is between low sal and high sal. If we wanted to use the actual inner join notation, well, we use that little bow tie symbol, and then underneath we write our condition. So again, low sal less than or equal to sal, and sal less than or equal to high sal. What does that look like in SQL? Well, let's use the implicit join syntax, and we simply go like this. The from bit, well, we're going to have emp comma grade, because those are the two tables that we want to combine. Our condition then is, as we've seen on the previous slides, sal has to fall between low sal and high sal. And then on the top line, I'm just going to say, show me ename grade, sal and the high sal. Just like that.